To wrap up Notes 19, let's look at how we would answer a question if someone asked us to interpret our y-intercept or interpret our slope for them. So remember that the estimated slope is the predicted amount of change for our y variable for every 1 unit increase in the x variable. So sort of a good general interpretation of your estimated slope is to say that the predicted value of the response variable will increase or decrease if your estimated slope is negative by that amount for every 1 unit increase in the explanatory variable. So this is sort of a template that we can use if we're trying to interpret our slope for someone. Now we're going to want to add context. We're going to want to say what this number is, what our response variable is, what units it's increasing or decreasing by, and all of that stuff. So for the burger example, we were trying to predict the number of calories, and we were using the grams of fat to do that. So since our slope was 11.95465, we could say that the predicted number of calories in a fast food burger will increase by 11.95 calories for every additional gram of fat in the burger. Or in other words, every 1 gram we increase the amount of fat, the predicted number of calories goes up by 11.95. And you'll notice that I underlined predicted in both of these sentences. That's sort of what distinguishes statistics from math a little bit, is that in math you're used to saying this goes up, this will also go up, or this goes down, this will also go down. But we've seen that there's not a perfect relationship here. Not every burger is going to increase by 11.95 calories if you add 1 gram of fat to it. And so this is just what we're predicting. It's sort of the average thing that will happen. All right? And so we're going to do something similar to this for the y-intercept as well. The y-intercept is the point on the y-axis that the line passes to. Another way of thinking of that is it's the y value when x equals 0. So we can set up sort of a template for how we might interpret this. We would say that our estimated y-intercept b0 is the predicted value of our response variable when the explanatory variable is 0. But again, for any specific example, if I ask you to interpret your y-intercept, you should add some context. You should use the actual number for b0. You should tell me what your response variable is, what units you're talking about, all of that. So for this one, our y-intercept was 165.84. And so we could say that the predicted number of calories is 165.84 in a fast food burger that has 0 grams of fat. And a lot of times, this predicted number of calories will be an extrapolation. A lot of times we won't have data anywhere near an x value of 0. So for this example, we didn't have any burgers where the grams of fat were 0. And if that's the case, you should still write out the interpretation if I ask you to do it, but you should probably add a note that says, you know what, this is an extrapolation. The least fatty burger we had was 19 grams of fat. You know, maybe a veggie burger would have 0 grams of fat, but that's going to be a very different kind of burger. So who knows if this prediction would be a very good one. All right, so that'll wrap up Notes 19. What you saw was how to find the best line for the data. We talked about the fact that this was an estimated line. Technically, if I had all the data for the population, there's some true line. I don't know what it is, so I estimate it. And that line I can use to make predictions. I'll plug in an x value and it'll give me a predicted y value. I can also tell someone how to interpret my estimated slope and how to interpret my estimated intercept. In the next set of notes, we'll sort of wrap up this idea of simple linear regression by going into some hypothesis tests and confidence intervals that we can do, and a way that we can talk about how good of a prediction we're getting, like how well our line actually explains what's going on.